the zero exponent law or the zero exponent rule, what that simply means that as we will do some examples, we'll see the result of the zero exponent. As we have seen before, that if we have 2 to the third power, that means 2 times 2 times 2, which gives us 8. That is true. Now when we have now negative 2 to the third power, that becomes negative 2 times negative 2 times negative 2, which is 8. But when we have negative 2 to the third power, notice the differences. We end up with negative 2 times 2 times 2, which gives us negative 8. There's a major difference. Here we cube the negative. Alright, so let's try one where we have a zero exponent. If we have anything, say for example 2 to the 0 power, that will give us 1. If we have 3 to the 0 power, that will give us 1. If we have a half to the 0 power, that is still 1. Now notice that the base, so long as the base is being raised to the 0 power, the value will be 1. Notice they're all positive. In this case we got 8, in this case we got 1. So note. Now what happens now when we have an exponent, a base? Say for example we have 500 over 1200, everything to the 0 power. Well, pause the video and think about it. Okay, I guess by now you should have gotten the answer after pausing the video for a while. The base here, if you can identify, it is this whole thing which is inside of the bracket. Therefore the base is being raised to the 0 power, which is still 1. So if you got that answer as 1, you're on the right track. Notice the values which we have been using are all positive. Now we will be introducing a negative value and see what then happens. Okay, so remember, so long as the base is in bracket, that is being raised to the 0 power. So if we have negative 2 to the 0 power, open close bracket, that will give us 1. Okay, but what about when we have negative 2 to the 0 power? How much is that? Well, negative 2 to the 0 power is different from open close bracket negative 2 to the 0 power. Two different scenarios. Therefore the base here is not the negative 2, but it's simply 2. Therefore we can say that the negative open bracket 2 to the 0 power, that is what is being raised to the 0 power, which then gives us negative 1. So in this case, this went against what we would understand. Everything to the 0 power is 1. In this case it is 1, what is to the 0 power, but because of the negative in front of the value, that became negative 1. Okay, so let's try our next one. If we have negative 2/3 to the 0 power, how much is that? Pause the video for a while, try solve it, and then come back. Okay, so you should have solved it by now. If you got the value here as 1, you're correct. Why? Because what is being raised with 0 power is the whole value as negative 2/3. Okay, so let's try our next one. Negative 2/3, and this is to the 0 power. Okay, if we have that, pause again the video and solve it. Okay, so if you got the solution for this to be negative 1, you're correct. Therefore anything to the 0 power is always 1, but because of the negative which was in front of the base, it became negative. So if we have abstract values, for example a cubed over b to the 4th power, and we put everything to the 0 power, that is still 1. Excellent. So if I have now negative a cubed b to the 4th, open close bracket, to the 0 power, that is now negative 1. So in this case, the value is the base. Well, the base is actually to a 0 power, not the negative. So therefore, when you solve this, you get negative 1. So remember, anything to a 0 power is always negative 1. Let's try to solve some other ones where we get 1. So let's try to do some proving at the same time. Well, we have done division of exponents, so we'll be doing some little division of exponents and getting the value of 1. So if we had a to a third power divided by a to a third power, according to our rules, it says that so long as you have a base to a m power divided by that base to a different power, we keep the base and simply subtract the denominator power from the numerator power, and that's our solution. Therefore, what we would do here, we would say a to a 3 minus 3, giving us a to a 0. This is not complete yet. This is going correct, but it's incomplete. Why? Because anything to a 0 power is always 1. Excellent. So therefore, your final step for such problem would give us 1. Not this. This is incomplete. This is the complete solution for this problem. Alright? So that's how you solve problems with a 0. So remember, if you end up with a base to a 0 power, that is incomplete. You need to proceed. Okay? Now, consider that you have a to the 4th divided by b to the 5th, a to the 4th. Okay, let's see how this works out. Well, according to the rules, it says that if a base is the same, these are the same, we'll keep the base and simply subtract the powers. So what we will do here now is as this. We will divide and then multiply, because notice what is being divided is this one here, not this. So therefore, our solution in this case would be a to the 4th over b to the 5th times a to the 4th. Notice there's a major difference. We had a problem like this in the previous exercise. We divide and then we multiply. This now would give us a to the 8th over b to the 5th. The powers will not be subtracted. Now let me give you an example where the powers makes it 1. So if I had now a to the 4th divided by b to the 5th, a to the 4th, but negative 4, our solution will be, well, it says divide, right? So we would minus, but then that would can become positive. So what we would do here is that we would do this: a to the 4th over b to the 5th. This a to the 4th, now it is still here that you're multiplying, okay, just like as this multiplication, and then that gives us now a to the 4th plus negative 4 over b to the 5th. That gives us then a 4 plus negative 4, a to the 0 power over b to the 5th. A to the 0 power is 1 over b to the 5th.